Hi guys, welcome back to Pipe versus YouTube channel where curiosity meets the code. Today our topic of discussion will be to you study about the UML, which is unlocking software design with UML, a visual guide. So let's start with the contents. So firstly, will be discussing what is UML, the key concepts of UML, types of UML diagrams, importance of UML, class diagrams, which is blueprint for objects, class diagram in action, which is library system. Then we'll be discussing regarding capturing interaction, introducing use case diagrams, key elements of use case diagrams in action, which is ATM systems. Then we are going to talk about sequence diagrams, then clarifying requirements with UML, improving communication with UML, and designing better systems with UML. So let's get started. Firstly, what is UML? UML stands for Unified Modeling Language, a standardized visual language for specifying, designing and documenting software system. What are the benefits if we use UML? We have clear communication, the bridge gap between technical and non-technical terms, and we have enhanced designs, which is visualize and refine software architecture before coding, improve documentation, that is maintain a consistent accessible overview of a system. Then we have reduced error, which is identify and address potential issues early in the development process. Next, what are some of the key concepts of UML? We have firstly objects, the real world entities with attributes and operation, example user, account, etc. Then we have classes. This is a template for object with shared characteristics and behavior. Then we have attribute, properties or data of an object or class, example username, balance, etc. Then we have operations. This is action for function performed by an object or class, that is example login or deposit or withdrawal, etc. Then we have the relationships. This is the connection between the object or classes, which is association, comma, inheritance, etc. Next, what are the type of UML diagrams? So firstly, a brief overview for common diagrams. Firstly, we have class diagrams. This shows classes, attributes, operation and relationship. Then we have use case diagram. We can capture interaction between actors and the system. Then we have sequence diagram, illustrate message flow between the objects in a specific scenario. And other diagram include state, collaboration and deployment, etc. Now, what is the importance of having a UML diagram? Firstly, we can increase clarity and efficiency. Improved communication reduces ambiguity and streamline development process. And then we have early problem detection, which is identify and address design flaws before costly implementation. Then we have enhanced collaboration, which facilitates communication and understanding between all stakeholders. Then we have scalability and maintainability, which creates adaptable and well-documented system for further expansion. Next, we'll briefly discuss few of the diagrams. Firstly, we'll go with class diagrams, which is blueprint for objects. A class diagram depicts the static structure of a system, showcasing its classes, attributes, operation, and relationships. And the purpose being model the core element of a system, visualize the overall system structure, communicate design decision effectively. Next, we have class elements and relationship. So firstly, we have name, the unique identifier for a class, typically a noun or a phrase, example customer, account or order. Then we have attributes, which is properties or characteristics of class specifying data and class holds, example name, address, balance. Each attribute has a name and a data type like string, integer, date, etc. Then we have operation, actions or function that a class can perform. Example, create order, calculate total, print invoice. They have a name, parameters and return type, and often have visibility modifiers like public, private or protected. Next, we have firstly association, a general connection between the classes indicating some kind of interaction or dependency. Then we have represented by a solid line connection the classes, and we have example a customer places an order. Secondly, we have inheritance, so represent as is a relationship where the child class inherits the attributes and operations from a parent class, denoted by a solid line with a hollow arrowhead pointing from the child class to the parent class. Example is a saving account is a type of bank account. Then we have aggregation. This is represent a whole part relationship where one class is composed of another class, but the parts can exist independently. Then we have denoted by a hollow diamond shape at a whole class end of a solid line. Then we have example, a car has an engine, but an engine can exist without a car. Then we have the dependency indicates that one class uses or relies on another class, but there is no structural relationship between them. It is represented by a dashed line with a arrowhead pointing from the dependent class to the independent class. Example, a customer services class depends on a customer class to access the customer information. So this is a typical class diagram in action. This is a system where the library works. So just pause and you can go through the types of lines, what are the classes used, what are the functions given here. So just pause and give a look about it. Next, we'll be going through walkthrough. So the key cases in the previous diagram, we have key classes. The books is a key class. Attribute the ISBN, attributes being the ISBN is a unique identifier. Like every book has given a unique ISBN. We have the title, author, genre, availability, and then operation that you can be done with the book is either borrow, return, or reserve. The second key attribute will be member. The attribute under the member will be name, ID, membership type, address, and contact information. The operation that you can do with member is borrow book, return book, renew book, or view borrowed books. The next will be the librarian. The attributes will be name, ID, role. The operation being add book, remove book, issue membership, renew membership, manage book, inventory. Then we have a book loan, the attribute being book ID, member ID, borrow date, and due date. The operation you can do with book loan will be calculate the fine. So you can find this in the entire diagram. Next, the relationship, we have association, member borrows the book, librarian manages the book, and member. The aggregation being book loan has a book and member, inheritance being consider subclasses for different book types, example reference book or periodically, or membership types, example student member, facilitate member, etc. Next, we can capture the interactions, which is including use case diagrams, which is the second type of UML diagrams. A use case diagram is a visual representation of how actors interact with the system to achieve specific goal. It focuses on the functionalities the system provides rather than its internal structure. Then we have the purpose. So purpose being use case helps capture user needs and expectations, ensuring the system is designed to meet them. Then we can identify key functionalities, which is clear outline the system's core features and services. Then we have identify actors involved, specify who interacts with the system in what ways. Then we have clarify system boundaries and scope. This defines what the system does and doesn't do, helping managing expectations and scope creep. Then we have improved communication, provides a visual tool for stakeholders to understand system behavior and requirements. Then we have guide development and testing. Serve a roadmap for development and testing activities, ensuring all functionalities are implemented and validated. So here, what are the key elements of use case diagrams? Firstly, actors. So represent external entities that interact with the system to achieve goal, denoted by stick figures or icons, can be humans, example customer library, external systems like payment gateway or other system, example inventory system. Second, we have use case. We have oval representing a specific functionality or services and system providing to an actor. Then we have labeled with a descriptive word such as search for books, place order, or even manage account. Then we have the relationship, connect actors to use case with solid lines indicating who can initiate or participate in each use case. Then we have scenarios, detailed description of specific sequences of steps within a use case, often numbered, capture the interaction between the actor and system to achieve the goal, not directly shown in the diagram, but crucial for understanding use case behavior. This is a typical example of a use case diagram. This is a ATM system. Pause it and we'll go through this diagram. So it's clearly given a customer, a administrator, what are the procedure and what is the final person connecting, which is the bank. So walkthrough, firstly we have actors such as customers and bank system, which is represented as an external system actor. The use cases being withdraw cash, check balance, deposit cash, transfer the funds or change the PIN, request mini statement. Then we have the relationship. This customer initiates all the use case except the request mini statement, which can be initiated by the system, or bank system is involved in all cases to validate transaction and update account information. Then we have common use case relationship, which include withdraw cash, includes verify PIN to ensure security. Then we have check balance, include print balance to provide the result. Then we have extend, which is transfer fund, extends withdrawal cash to add the transfer functionality. Then we have request mini statement, which extends the check balance to offer additional transaction history. Next, the third type being sequence diagram. A sequence diagram captures the dynamic interaction between the objects in a specific scenario, showcasing the sequence of messages exchanged over time. It focuses on temporal aspects of object communication, revealing how they collaborate to achieve a task. So what is the purpose of having the sequence diagram? We can visualize the object communication and collaboration, illustrate how objects work together to fulfill a system's functionality, and then we analyze system behavior in detail. We understand how objects interact under different circumstances, revealing potential issues or bottlenecks. Then we have model complex interaction. This handles scenarios involving multiple objects and conditional logic. Then we validate design decision. This ensures objects that are designed to interact correctly and efficiently. Then we have guide implementation to provide a blueprint for developers to code object interaction accurately. Then we have facilitate testing, which helps create test case to verify object behavior and message flows. Next, we have having clarifying requirements with the UML. So for class case diagram, we clearly define a class and their attributes, ensuring everyone understands the data representation. Then we have to identify potential missing attributes or data inconsistencies. Then we have visualize relationship between classes, uncovering potential ambiguities in functional requirements. Then for use case diagrams, we have captured user goals and functionalities for their perspective, reducing the misinterpretation. Then we have identifying missing incomplete use case, ensuring all the users' needs are addressed. Next, improving communication with UML. What are the steps you can do to improve the communication with UML? Firstly, shared languages. UML diagrams provide a visual languages understanding by both technical and non-technical stakeholders. Then we have unified understanding, bridge the gap between developers, analysts, designers, and user, enhancing collaboration. Then thirdly, early feedback, use diagrams to solicit feedback at early stages, catching issues before costly development time. Then we have the documentation accuracy. Diagrams serve as a visual documentation, reducing communication ambiguity and maintaining consistent understanding. Next, we have designing better systems with UML. The early problem detection analyze the object interaction and messages flaws in sequence diagrams to identify potential design flaws. And next one will be modular and maintainable design. The class diagrams promote well-defined independent classes, leading to easier code maintenance and updates. Then we have scalability and flexibility, which is UML helps anticipate further system growth and adaptation by modeling different scenarios and relationship. Then we have reduced developmental risk, which is UML diagrams uncover potential issues early, leading to more efficient and reliable development processes. So that's it for the UML diagrams. Let me know in the comment down if you have tried to build a UML diagram by your own, any kind. So this is it for today. Thank you so much for watching. If you have learned something from this video, please do like, share and subscribe to our channel for more information. Thank you.